In section 7.2, we are adding and subtracting rational expressions. Our objectives are to add and subtract rational expressions with the same denominator, find the least common denominator, and add and subtract rational expressions with different denominators. Before we jump into adding and subtracting rational expressions with variables, let's do a quick review of how we add fractions in general. For example, if we have a fraction 3/7 plus 2/7, if the denominators are the same, you add the numerators together. So you get 3 plus 2, which is 5, but you keep the same denominator. So 3/7 plus 2/7 is 5/7. However, if the denominators are different, something like 1/4 plus, say, 3/10, we would want to first get a common denominator. Now the least common denominator of 4 and 10 is the least common multiple of 4 and 10. So if you list all the multiples of 4, you get 4, 8, 12, 16, and 20, and list the multiples of 10, 10, 20, and 30. The least common denominator is that least common multiple. In this case, our least common denominator is 20. So you would have to multiply the first fraction by something so that you would get a denominator of 20, and the same thing with the second fraction. So you would have to multiply 1/4 by 5 so that you would get the denominator of 20. Now if you multiply the denominator by 5, you also need to multiply the numerator by 5. Now the same thing with the fraction 3/10. You must first get a common denominator. So you would have to multiply 3/10 by 2. If you multiply the numerator by 2, you must also multiply the denominator by 2. So adding these two fractions together, you must first get a common denominator. 1/4 is equivalent to 5/20. And 3/10 is equivalent to 6/20. So now that the denominators are the same, you can add the numerators together to get the result of 11/20. Keep that in mind when we are doing the adding and subtracting rational expressions with variables, that we can only add and subtract rational expressions if the denominators are the same. If the denominators are not the same, we need to find the least common denominator and make sure both fractions have that same denominator. Now, adding and subtracting rational expressions is given on this slide as a two-step process. If the denominators are the same, you add or subtract the numerators, place the result over the common denominator. If the denominators are different, first find the least common denominator, write all rational expressions with this LCD, and then add or subtract the numerators. Place the result over the common denominator. And step 2 is simplify. Write all answers in lowest terms. Now, the way we go about finding the least common denominator for rational expressions is that we must first factor each denominator and then find the least common denominator, which is the product of all the different factors from each denominator, with each factor raised to the greatest power that occurs in the denominator. Okay, for this example, we are adding two rational expressions with the same denominator. For part A, we have 4m divided by 7 plus 5n divided by 7. Since the denominators are the same, we add the numerators together. When you add the numerators, you get 4m plus 5n, which is 4m plus 5n. They are not like terms, so you can't combine them into a single term. But since the denominators are the same, we're going to keep that common denominator of 7. So our result, adding those two rational expressions together, gives us a single rational expression that has the same denominator. And for example, B, we have the first rational expression, 1 over g to the third minus 5 over g to the third. Since the denominators are the same, you are going to subtract the numerators. When you subtract the numerators, 1 minus 5, you get -4. And you want to keep that common denominator of g to the third. And if possible, you simplify. This can't be simplified even further, so our answer is -4 over g to the third. Here's another example where we're adding or subtracting rational expressions with the same denominators. Now notice that both fractions have the same denominator, so we can simplify this by subtracting the numerators. So when we subtract the numerators, we have a minus b in the numerator, and in the denominator we have the common denominator of a squared minus b squared. Now we do want to factor and simplify this rational expression. Notice that the denominator is a difference of two squares that can be factored. So let's rewrite the denominator of a squared minus b squared, write it as a plus b times a minus b. So we have found those two binomial factors. Now we simplify if possible. The numerator has a factor of a minus b, and the denominator has that common factor. So these we can divide out. Our answer must have a numerator, so we are going to write that numerator of 1. And the denominator, the remaining factor, is a plus b. So our final answer is written as 1 over a plus b. In this example, we are adding rational expressions, and notice that the denominators are the same, so we can add the numerators together. The numerator, we have 5 plus k, and since the denominators are the same, it's a common denominator, we keep that denominator of k squared plus 2k minus 15. Now this rational expression may be simplified, and we do that by factoring the denominator. We'll keep the numerator as 5 plus k, and the denominator is a simple trinomial. So we're looking at the factors of negative 15 that will add to give you positive 2. So we'll see that one of those factors would be k plus 5, and the other factor would be k minus 3. The factors of negative 15 that will add up to positive 2 are positive 5 and negative 3. So our corresponding factors are k plus 5 and k minus 3. Now notice this numerator is 5 plus k, and the denominator has k plus 5. These are like factors. They have common factors, so that can be simplified by dividing those common factors. Our result is the fraction, with the numerator have being divided out, simplified, we must put a numerator of 1, and the denominator is that k minus 3 factor. So our final answer can be written as this simplified rational expression. Now there will be cases where you're adding rational expressions without common denominators, so you would have to first find the least common denominator. In the next examples, we'll be looking at each denominator on its own and finding the greatest common factor. For this example, we have 4m cubed n squared. That's the first expression, given that that is a denominator, and 6m squared n to the 5th is also a denominator of fractions. We want to find the least common denominator for each group. We can factor 4 as 2 times 2, and we have m cubed n squared. We can factor 6 as 3 times 2, m squared n to the 5th. Now our least common denominator is going to be represented with each of those factors, the greatest exponent for each factor. And 2 times 2 is our 2 squared. That is going to be part of our least common denominator. Now the 2 in the other denominator is already represented by that 2 squared. We will have 3 as part of the denominator, as well as the greatest exponent for the variable factors. M to the 3rd will be part of our least common denominator, and n to the 5th will be part of our least common denominator. So our LCD is going to be 2 squared times 3, m to the 3rd, n to the 5th. 2 squared is 4 times 3 is 12, so our LCD can be written as 12 m to the 3rd, n to the 5th. if we were adding two fractions together with the given denominators, we would have to make sure both denominators can be written as the least common denominator in order to add or subtract. Alright, in this one we want to assume that the given expression are denominators of fractions. Find the least common denominator for each group. The first term is y minus 5. Since that is in itself a factor, that has to be part of our LCD. Our LCD is going to have y minus 5 as a factor since y minus 5 is a denominator, and the LCD is also going to have that factor of y. So the LCD can be written as y minus 5 times y, or it can be written as y times y minus 5, and we typically leave our denominators in factored form. Alright, let's take a look at this example where we assume that the given expressions are denominators of fractions. Find the LCD for each group. In this case, we're going to have to factor first so that each factor is represented as part of our LCD. These are both simple trinomials. So we're looking at the first one to find a factor of the pairs of factors of -10 that will add to give you -3. And the factors there would be n minus 5 and n plus 2. For the second expression, we also have a simple trinomial. We're looking for the factors of 15 that will add to give you -8. And the factors there would be n minus 5 and n minus 3, because the factors of 15 are -5 and -3, and when you add those you get -8. So the LCD is going to have all the different factors that are represented. We have an n minus 5 as part of the first factor, as well as an n minus 5 that appears in the second denominator. We have a factor of n plus 2 that is represented, as well as the n minus 3. So in this case, the least common denominator would have those three factors. Before you add and subtract any rational expressions, you want to make sure that each fraction can be written with that least common denominator. Okay, assume that the given expressions are denominators of fractions. Find the LCD for each group. We need to factor each of these before we find the LCD. Find the greatest common factor of 4h squared minus 12h. The greatest common factor is 4h. If you factor out a 4h, what you'll have left from the first term is h, and a minus 3 from the second term. We also want to factor 3h minus 9, the common factor here being 3. If you factor out a 3, you get h minus 3. So our LCD is going to have represented each of these factors. Looking at just the coefficients, we can see that we have 4 and 3. If those were denominators of simple fractions, the least common denominator would be 12. Now, the first expression has a factor of h, so that is also going to be part of our LCD. The first has a factor of h minus 3, so that is also going to be part of our LCD. The other h minus 3 term factor that's in the second denominator is already represented, so we don't need to add another one. This would be our LCD for these two given denominators. All right, let's look at this group. We need to factor first before we find the least common denominator. And again, we're assuming that these given expressions are actually denominators of fractions. The first denominator is a simple trinomial, which can be factored by looking at the factors of 1 that will add up to -2. And we have those factors are g minus 1 times g minus 1, which can also be written as g minus 1, the quantity squared, since that's a perfect square trinomial. The second one can be factored looking at the factors of -4 that will add up to +3, one factor being g plus 4, and the other factor being g minus 1. And the last term can be factored by taking out the greatest common factor of 5, and what you'll have left is g plus 4. So we want to make sure our least common denominator is going to have all of these factors represented. Our g minus 1 squared will be part of the least common denominator. The second g plus 4 here factor will also be part of the least common denominator. The g minus 1 is already represented in this first factor of g minus 1 squared. We don't need to add that again. We have a 5 here as part of our LCD. And then the g plus 4 is already represented in this least common denominator. So our least common denominator for all three of those expressions would be 5 times the quantity g minus 1 squared times the quantity g plus 4. All right, now let's get to actually adding and subtracting rational expressions with different denominators. We need to first find the least common denominator, the LCD, looking at 3z and 9z. The least common multiple of 3 and 9 is 9. And since both denominators have z, z is part of our least common denominator. We want to make sure each of those denominators are expressed as 9z. So the first fraction is missing part of this LCD. If we were to multiply the first fraction by 3, we would end up with a 9z in the denominator. But we also need to multiply the numerator by the same thing, otherwise we're changing the value. So then we get 3 times 7, which is 21. 3 times 3z is 9z, plus 1 over 9z. Now we have these two fractions with a common denominator. We can find the result by adding the numerators. 21 plus 1 is 22, and keeping that same denominator of 9z. That would be our final answer. If possible, if it were possible to simplify it, we would do that next step. This is as simple as you can write this fraction, so we're going to leave it as 22 over 9z. All right, for this example, we are adding and subtracting rational expressions with different denominators. We need to first find the LCD, the least common denominator, for both of these fractions. The first fraction has a factor of y. That is going to be part of our LCD. The second fraction has a denominator of y minus 4. That as a factor will also be part of our least common denominator. So we need to multiply each of those fractions by whatever is missing from the least common denominator. For the first one, we have the y, but we don't have the y plus 4. So we're going to multiply the first fraction by y minus 4. If we multiply the denominator by y minus 4, we need to multiply the numerator as well with 9 minus 4. When we distribute the y here, the y minus 4, distribute the 2, we get 2y minus 8 in the numerator over y times y minus 4. We do want to keep the denominator in factored form. Now let's look at what's missing from the second denominator. We already have the y minus 4, so the missing part is that factor of y. We're going to multiply the second denominator by y, but if we multiply the denominator by y, we must also multiply the numerator. So that will give us minus 3y in the numerator over that common denominator of y times y minus 4. Now that we can see that the denominators are the same, we could add or subtract the numerators. In this case, we're going to be subtracting so that we get in the numerator 2y minus 8 minus 3y all over that least common denominator of y times y minus 4. Now let's simplify the numerator by combining like terms. We have this minus 2y, positive 2y minus the 3y. Those are like terms, so we can simplify the numerator as 2y minus 3y, or a negative y minus 8. And the denominator, keep that in factored form to get y times the quantity y minus 4. And that would be our final result of subtracting those two rational expressions with different denominators. The first thing we do is find the least common denominator, and then you multiply each of those fractions so that you can get that least common denominator, and then combine the numerator. Now, word of caution with subtracting rational expressions. One of the most common sign errors in algebra occurs when a rational expression with two or more terms in the numerator is being subtracted. So again, look carefully at this example here. The first fraction, we're subtracting the entire fraction here. The denominators are the same, but you want to subtract this entire numerator. So what you can do to keep it straight is to distribute that negative sign and write it as the negative d plus 6, or minus d plus 6. And then you can combine the numerators. So again, one of the most common errors is that you're forgetting and only subtracting the first term, but keep in mind that you're subtracting the entire quantity. All right, let's take a look at this example. Using the distributive property when subtracting rational exponents. We want to first find the LCD, the least common denominator. Each denominator can be expressed as a factor. E minus 2 is the first denominator, so that's part of our LCD. And E plus 2 is the second denominator, so that's also going to be part of our LCD. Whatever is missing from each of those fractions, we're going to multiply. The first one is missing a factor of e plus 2. So I'm going to multiply that by e plus 2. And if I multiply the denominator by e plus 2, I must multiply the numerator by e plus 2. And for the second fraction, the missing factor is e minus 2. So I'm going to multiply the denominator by e minus 2 as well as the numerator by e minus 2. When I simplify the first fraction by distributing the 2 in the numerator, I get 2e plus 4 over e plus 2 times e minus 2. For the second fraction, I'm distributing the 9 here, 9e minus 18 over e plus 2e minus 2. We do have a common denominator, so we can subtract the numerators. But this is where you want to keep in mind that you are distributing the negative. You're subtracting both of those quantities. So when we write this as a single fraction, the numerator is 2e plus 4 minus 9e, as well as minus a negative 18. And this minus a negative ends up being a plus. And our denominator is that LCD of e plus 2, e minus 2. Now in the numerator, we can combine like terms. We have a 2e here and a minus a 9e. Those are like terms. And we have the plus 4 and the plus 18. Those are like terms, so we can combine those. Our numerator, when we simplify, 2e minus 9e is negative 7e. And then the plus 4 and the minus negative 18 or plus 18 is plus 22 in the numerator. And our denominator is our LCD of e plus 2 times e minus 2. And that would be our final answer, which is a result of subtracting those rational expressions, first finding the LCD, and then combining the numerators. All right, in this example, we're adding rational expressions with denominators that are opposites. We have 4 divided by x minus 5 and x divided by 5 minus x. Well, let's think about 5 minus x. And going back to a previous section, we looked at how we can factor out a negative. If we write this as negative x plus 5 and factor out a negative, the result is going to be an x minus 5. So we can write this second denominator as a minus instead of a plus. So the first fraction we'll leave as 4 divided by x minus 5. And I'm going to replace that denominator of 5 minus x with a minus, and in parentheses, x minus 5. So this minus that's in the denominator, we can bring that out in front of the fraction so that it can be written as 4 over x minus 5 minus x over x minus 5. Now, looking at it this way, we already have a least common denominator is already x minus 5, so we can combine the numerators. In the numerator, we're going to have 4 minus x, and the denominator would be our LCD of x minus 5. That would be our final answer, simplified. All right, in this example, we're adding and subtracting 3 rational expressions. So we still want to find the LCD. Before we find the LCD, let's make sure each of those denominators is in factored form. The first fraction has a denominator of n plus 3. It can't be factored further. The second fraction can be written as 2 divided by, that common factor here is n. So that would be n times n plus 3. And then the last fraction, 4 over n. Now out of these fractions, we can determine the LCD. The LCD, least common denominator, will have a factor of n plus 3. That'll take care of the first one. It'll take care of the part of the second fraction, so we need to have an n as well, and that will all be represented here. Our LCD is n times n plus 3. We can multiply each one of these fractions by whatever is missing so that we can add these fractions together. The first fraction denominator is missing the n, so I can multiply the first denominator by n as long as I multiply the first numerator by n. The second fraction already has the least common denominator, so there's no reason to multiply by anything for the second fraction. The third fraction, however, is missing that factor of n plus 3, so we can multiply the denominator by that factor of n plus 3 as long as we multiply the numerator by n plus 3. Now let's simplify each of these fractions. N times 3, we get 3n over the LCD, n times n plus 3. The second fraction, just rewriting it. And the fourth fraction, if we distribute the 4, we get 4n plus 12 over the LCD. Now that all of those denominators are the same, we have that LCD, then we can add those numerators together. So the numerator is going to be 3n plus 2 plus 4n plus 12. The denominator is n times n plus 3. We can go further here and combine like terms. The 3n and the 4n are like terms, and the plus 2 and the plus 12 are like terms. When we combine those, 3n plus 4n is 7n, and 2 plus 12 is 14. In the denominator, we have n times the quantity n plus 3. It looks like we can factor the numerator as well. You can factor a 7 and get n plus 2, and n times n plus 3. Let's leave our answer in this form. So we are able to take these 3 separate rational expressions, find a least common denominator, add the numerators, and simplify to get a single rational expression. All right, for this example, we are subtracting rational expressions. We do need to make sure we have a least common denominator, but before we find that least common denominator, we need to factor each of the original denominators. The first fraction, a minus 2 in the numerator, and in the denominator, if we factor this simple trinomial, the factors of -3 that will add up to positive 2, the factors would be a plus 3 and a minus 1. Minus the second fraction numerator is a plus 2. If we factor the denominator of the second fraction, we are looking at factors of 4 that add up to -5. So those factors would be a minus 4 and a minus 5. Sorry, a minus 1. Let's go back. a minus 1. So our LCD would have to contain each one of these factors. We would have an a plus 3, an a minus 1, an a minus 4, and an a minus 1. Since we already have it represented there, we don't need to add it again. We're going to multiply by whatever the missing factor is in the LCD. The first fraction is missing that factor of a minus 4. So we're going to multiply the first fraction by a minus 4 as long as we multiply the numerator as well by a minus 4. The second fraction is missing the a plus 3 factor. So we're going to multiply the numerator by a plus 3 as well. So let's look at each individual fraction. The first one, when we multiply using the FOIL process, the first, outer, inner, and last, we get first is a squared, the outer is minus 4a, the inner is minus 2a, and the last is plus 8, all over those three factors that are part of the LCD. Minus what we get when we multiply the numerator doing the first, outer, inner, and last. We get a squared plus 3a plus 2a plus 6 in the numerator. And then the denominator, we have our LCD, a plus 3, a minus 1, and a minus 4. Now that we have both fractions written with the least common denominator, we can write this as a single fraction. And in the numerator, we have a squared. I'm going to combine these like terms here. Minus 4a minus 2a. Those are like terms, so I'm going to write this as minus 6a plus 8. Now be careful here in our next step because we are going to distribute this negative, distribute it to each one of these terms. So we are subtracting that entire quantity. So we're going to have a minus a squared minus 3 and minus 2 is going to give us minus 5a. And then finally minus that plus 6 is minus 6. All over that least common denominator of a plus 3, a minus 1, and a minus 4. Now let's combine like terms in the numerator. We have the a squared minus this a squared. Those are opposites, so we'll end up with 0. For the a terms, we have minus 6a and minus 5a, which is minus 11a. And then with the constants, the plus 8 and the minus 6, that is going to be plus 2. So in the numerator, all that simplifies to negative 11a plus 2. In the denominator, we can write each of those factors as part of the LCD. So our final answer can be expressed as a single rational expression. All right, let's do one more example of adding rational expressions. We want to find an LCD, but before doing that, we want to make sure each fraction is written in factored form. For the first example, first fraction, we have a numerator of 2, and the denominator can be factored as to b plus 2 times b plus 2, which is the quantity b plus 2 squared. The second fraction, numerator is 8, and the denominator can be factored as b plus 2 times b plus 1, as that's a simple trinomial, and the factors of 2 that add up to 3 are plus 2 and plus 1. Now let's find our LCD. The LCD is going to have the greatest exponent of any of those factors. So b plus 2 squared, that quantity squared, is part of our LCD. So that's covered in the first fraction, as well as the b plus 2 in the second fraction is covered with that. Now what we're missing here is the b plus 1. So our LCD is a combination of all of those individual factors. Now we get to multiply by whatever is missing, the missing factor. In the first fraction, the missing factor is b plus 1. So we can multiply the denominator of the first fraction by b plus 1 as long as we multiply the numerator by b plus 1 as well. So that first fraction, we can write it by distributing the 2 as 2b plus 2 in the numerator over b plus 2 squared and b plus 1. The second denominator is missing a b plus 2. So because the LCD is b plus 2 quantity to the second power, we need to multiply by another b plus 2 in the denominator as well as the numerator. Now when we multiply the numerator, we can distribute the 8 to get 8b plus 16 in the numerator over that common denominator of b plus 2 quantity squared times b plus 1. Now that we have the like denominators, both denominators are the same, we can add the numerators together. So the numerators 2b plus 2 plus 8b plus 16 over that least common denominator of b plus 2 quantity squared times b plus 1. Now let's combine like terms in the numerator, the 2b and the 8b, and the 2 and the 16. We can combine those to get 10b in the numerator plus 18 all over b plus 2 quantity squared times b plus 1. The numerator looks like we can factor a 2 out of both of those terms, and we can write this as 2 times 5b plus 9 all over that LCD of b plus 2 quantity squared times b plus 1. That would be our final answer, adding those two individual rational expressions and combining them to a single rational expression.